Evening Blaster peeps. We're going to do the video of shimming metal gears in a nylon J10 box this evening. Something that a lot of people have been requesting, and I have been resting on my laurels a little bit doing this video, but we're here tonight, so let's smash this how-to out, and I'll tell you guys how I do it. I'll also do a couple little tips and tricks that I do in how to make this box a little bit more reliable. Just fix up some manufacturing faults that I've realized and found out, so that we can fix a few of your other issues. I'll give shout outs to people that have given me tips along the way, and yeah, we'll go from there. So I've been working on a little project of mine for son of one of our followers, so Adam. This is Nate's gearbox. He's happily named his blaster Derek. So we've put it all together. We've ran a couple mags through her, and what I normally do is after I do that, I pull it all apart, inspect all the components just to make sure we're getting good wear and everything's where it's supposed to be. I'm really happy with how all the internals are. There's just one little thing that I've got to fix up, which is, I'll show you guys, is the anti-reverse latch. So this is a Retro Arms anti-reverse latch, little CNC component. Got some pretty good contact. Whoop, there we go, contact right there. What I'm not happy with is we've got a little bit of contact on the back there as well. So after doing a little bit of inspection in regards to a standard anti-reverse latch, the profile of this anti-reverse latch is slightly different. So we'll modify this latch to fit our gel ball application, and we should be sweet. I've already given Adam a little teaser, a little video of it firing. He sounds really happy about it. I'm really happy. So the specs that we got out of this bad boy is 330 FPS, oh actually it was 336 FPS, really consistent at 25 meters, just trying to get it to go to about 30 meters, which should be just a little bit of a barrel and barrel change. So we'll mess around with that. Also, rate of fire was 28 rounds a second, so I'm happy with that as well. Accuracy at 25 meters is a little bit more of a spread than I like, so probably looking at about maybe 6 or 7 inches, so we've got to tighten that up, just changing a few hop-up designs just to try and get that to be a little bit more tighter. We'll do a barrel change as well, which should help us which should help us hit those goals. Also, side note, the gels that I was using are a couple weeks old, which I tend to do for the first 10 to 20 mags because I'm not really too concerned about accuracy at that point. I just want to make sure the mechanicals are working. So next fire test will be with nice fresh gels, and we should get really good results. So here we have the bottom half. So when I call the bottom half of the gearbox is, who have we got here? Yo, what's happening, Ivan? Thanks for joining us, man. Everyone else who's checked in, thanks for your support. Darren, Tenny, Benny, who else we got? Dan, Evan, Tristan, Nick, Kim, Brian, Trick. Yeah, so everyone that's joined us, thanks for your support. I always try and endeavour to supply you guys with as much information as I possibly can as we find it. We'll pass it on so that you guys can mimic what we do. Yeah, we can give you some good tips. Now, when I do these videos and I try and pass on the information to you guys, I do 2 different methods. What I mean by that is, as everyone knows, I have access to a fabrication room, so I'm able to use machinery to mod these boxes and components. But when I do these videos, I like to show you guys what tools I use in regards to DIY at home, seeing as not everyone has a lathe and a mill and all the machinery at home. If you do, good, you'll get a lot better consistency out of your mods. When I need to mod these things, I do 10, 20 of these builds, so I need to be as consistent as I possibly can across the whole range. You guys can, you're only doing one for yourself or a couple for your mates, so with all these hand tools and little tips and tricks that I can pass on to you, it'll make it a lot easier for you guys. Now, the reason why I touch up on that point is because we have, here we go, so there's your spur gear. So one of the main problems that people will see is the spur gear will be too long to fit inside this gearbox. Now, I've modded this gearbox to accept the spur gear. So what I normally do is, if I get a brand new gearbox, which I have one here, I wanted to show you guys in comparison. This is my replacement box for the high RPM J10 that I created a few weeks ago that destroyed the box. Where's a spur gear? Now, always say, when you guys take the top of the box off, always double check that there's no shims left on these bearings. So it's just second nature to me now, so I'll always harp on about the little things so that you guys can adopt it. So we've got a spur gear in a brand new box, and that is really tight, which I expect it to be, because they're always longer than what needs to happen. Let's get a proper angle happening here. Let's try a bit of that. There we go. So where are we? Here we go. Let's see if you guys can get it. That is super tight. I can bet, well, it can't really turn. I'm using a lot of force to get that spur gear to turn. So how do we rectify that? I've touched base on a few methods in the past, i.e. people shave down the shaft to get some room, which is really hard to do it at home. Methods to do that at home are using a drill, clamping the gear shaft in the drill, and effectively making a DIY lathe out of the drill with a file. You do run the risk of mushrooming the shaft, and if you do that, then it's going to slop around in the bushing. The safest way that I recommend you guys do it is, because it is a nylon box, it's really easy for you to shave down the bottom of this box. I'll pull out that other gearbox just so I can show you why I do what I do, and I'll show you the differences in my modded box and a non-modded box. So you can see here that there's a little bit of there's a lot more meat on top of that bushing, so you can recess that bushing up. On the bottom of it, it's nice and flush, so I don't really touch that side because there's not that much support for that bushing, which is surprising because in this gearbox the meat was on that side here. So this bushing had a lot more meat there, so I decided to shave out that side of the gearbox so I can recess the bushing in further, which will give us more room. That's the top half of this box, so you can see how that's flush. So there's no way that I want to take any more meat out of that because it'll make it too weak, whereas the top half of the new box that I got, there's a lot of meat there. So what I'll end up doing is I'll shave out that, so I'll recess that bushing further down, which will give me more room and give me the available space I need to shim the gears. So I was talking to Lockie over at GBA this afternoon, and I was explaining, how I do these things. He's also mentioned that sometimes he's had to do it with the bevel gear. I've never come across that. So, but by all means, if it's tight on the bevel gear, then do the same process. Have a look at where the bushing sits in the gearbox, and if you find that one side has a little bit more meat than the other, then yeah, by all means shave down that side of the gearbox to recess that bushing, and you'll find that you'll get a lot more room to be able to shim. You don't want to go too far in regards to taking out too much for two reasons. One, you'll decrease the strength in that section of the gearbox for the bushing, and two, you'll end up using a buttload of shims just to shim it back up. But then again, you don't want to go not enough, because if you only got 0.1 of a gap, you'll find that that'll be really hard to set the gear heights in relation to the other gears. So just got to hear what I miss. Didn't miss much, bro. I suppose you can rewind once I finish this live feed and go over everything. I'm just explaining to people how I recess these bushings into the plastic nylon box. You've actually come in at a really good point, because I'm going to show you the tool that I use, or what I would recommend to use when you do it by hand, and that is a step drill. Why do I use a step drill? Well, I use a step drill, and then there's a hand tap. So I use a step drill because of the steps. So it has a shoulder. See if I can get a good, where are we? Focus. There we go. Because it has that step in it, it'll still maintain the shoulder you need for the bushing to sit in. I was also talking to Lockie over at GBA. He mentioned that they use when they do this process, they use the Dremel. I just find that this is a little bit more consistent. You don't want to take off too much, and you don't want to go too vigorous. It just increases your chance to, well, lack of better words, fuck up. With this, don't forget, if you do utilize a step drill, it has two cutting edges. So you've got one cutting edge here. Boom. Got one cutting edge on one side. Oh, there we go. There we go. One cutting edge there. And if you turn it over, your cutting edge is here. And then if you turn it over, the next cutting edge is there. So why I mention that is to cut out a full circle, you only need to do half a turn. Now, if you're going to attempt this for the first time, ensure that this sits directly straight up and down. If it is off on an angle, you will cut more out of one side than the other. You can rectify that by favoring the other, by tilting the drill bit more to one side. And how you can tell if you're off center is when you place the bushing back inside here. That'll be off center, so you'll find that the bushing will sit cockeyed. So you can work it around just a little bit, just so you can get that bushing to sit nice and flush. As you can see, I've worked that bushing to sit pretty much right on point. I always run my finger over the edge just to feel the height difference around the edges of the bushing. And once I'm happy with that, then, you know, we can glue that in place and continue on with our shimming process. Once you create enough room for your metal gears, then it's just a straightforward shim job. There's a heap of videos on YouTube on how to shim, so I'll just quickly run through how I do it and why I do it. I think I've touched base on it before, but people that are tuning in for the first time and wanting to know exactly how I do it and why I do it, we'll just quickly run through it. I won't go through the whole process. There's other videos that I have. I'm wondering if I have them on here or if they died with AGBE. If you guys want a proper shimming video, then by all means comment and I'll sit down and do a proper shimming video. Just got to go through my archives to see if I've uploaded one on here for you, but we'll just quickly touch base on this. So I always start with the bevel gear. I'll drop the bevel gear in there, drop in top plate, and initially I'll just put a little bit of pressure there and just double check to see how much movement is in that shaft going up and down. If there's a lot of movement, then I'll throw in a couple shims. With this one, I think I started off with a 2 shim, 0.2 on the top and a 0.1 on the bottom. Now once you get it relatively close, or there's very, very, very little amount of movement without any screws in there, put all the screws in. Because with shimming, the best thing to do is to keep everything consistent. So you want to know exactly, you want to replicate the environment that that gear sits in. There's no use using clamps. There's no use holding your fingers down on it, because that is not how it lives inside your blaster. How it lives inside your blaster is with all the screws in there. So put all the screws in there, torque it down as per normal, nice and firm, and then double check your shimming. So when I go to check my necks to see if I need to put shims in or take shims out, I always check shaft movement up and down. If there's too much shaft movement, then I put in another shim. And I keep on putting shims in. It doesn't matter at this specific point in time at which position you put the shim in, i.e. put it on the top of the gear or you put it on the bottom of the gear. At this point in time, all you're trying to do is take up the slack between your gearbox and your gear. So I call that working out your parameters. So you're working out your boundaries that you need. So you're working out exactly how many shims it takes to shim that gear. Once you work out exactly how many shims it takes to shim that gear, you don't need to shim it anymore. All you're doing is adjusting the gear height by shifting shims from the top to the bottom. You're raising the gear by shifting shims from the bottom to the top. You're lowering that gear. So you work out your parameters on each 3 gears separately. The reason why you want to do it separately is because if you have multiple gears in there at the same time and you're trying to shim 3 gears at the same time, you are going to come across issues if the gear fouls on the other gear. So if you keep on trying to take shims out or put shims in and it's resting on another gear, you're gonna fuck yourself up. So do them separately. Once you work out, so after you work out how many shims it takes to get that movement out of the shaft, I then do a rotational test. So check out how much, here we go, check out how freely that gear moves. If it's tight, then I'll take off a 0.1 shim until that rotational movement is nice and free. It is much easier for you to keep on testing and adding 0.1 to it. Just give me 1 second, guys. Oh, and we're back. There we go. Just clearing some messages. People are blowing up my phone. So I would much rather, if you're doing it for the first time, I would much rather you guys keep on shimming until you find it's tight. So you've gone too far. You've experienced what it is when it's too loose. You've experienced what it is when it's too far. And you just back it off 0.1 until you get that gear or any of the gears to rotate nice and freely. It is also okay to have a very minor amount of movement in that shaft. You'd much rather have a little bit of movement in that shaft than have it too tight. If it's too tight, you're going to put a lot of stress on your motor. You're going to increase the heat. You're going to increase the resistance running through, or the current required to move those gears and rotate that gearbox. So you've checked out you've got your parameters on the bevel gear. Doesn't matter where the shims are positioned at the specific point in time. Once you do the bevel gear, then you shift to the I shift to the spur gear. Then I do exactly the same process with the spur gear. Then I put that to the side. I did exactly the same process with the sector gear. I then put that to the side. Now with the J10s, the next step is very, very interesting. I still adopt the fact of using the half shell method. So that is utilizing getting the top half of the gearbox, putting it into the grip. But the thing with the J10 is the grip is part of the bottom half of the receiver, so it does make it a little bit fiddly. So let me get another better angle. Here we go. So that's your grip and receiver. So I do drop that inside there. I do put 2 screws. Oh, can't really see. I do put the 2 mounting screws for that bottom half of the gearbox in. You can, let's see if I can get a light in here. Boop. There we go. You can just, if you're good enough, and it is possible, to wiggle this bevel gear in and out of that gap there, so you can test motor to pinion height. It is a little bit more fiddly with the J10. I do recommend, or I do it this half shell method way. I find it is a little bit more consistent. I've been talking to Sammy over at Bruisemaster. He has a different way of doing it, and you know, I tried to adopt that method in this respect because it doesn't utilize the half shell method, but I didn't really. My personal preference wasn't towards his method. Each to their own. He's been doing it for a while, and he reckons he hasn't come across any issues. I've been doing this way for a while, and I haven't come across any issues. I just figured I'd try a new method just to see if it does work better. I didn't personally like it, so I switched back to doing the half shell method in this blaster, and it came up trumps. So when you do that, let me see if I've got his motor here. There it is. I'll just set this one up, guys, just so I can show you what I mean. All right. Whoop. See if I can. Oh, that's a pretty good angle. Let's see if we can keep it like that. So as you can see, there we go. That motor goes in there. Well, a little bit of lighting difficulties. Oh, battery's gonna go. What I normally do is once you set your motor height, so that's by adjusting the screw in the base plate of the grip, and then what you need to do is just check that there's movement here. So I have a bit of movement there, and also you want to check rotational movement. So there's a little bit of rotational movement there, which is good. So like I said, I've already shimmed this. If you find that there's no movement going back and forth, oh, hold up, guys, I'm going to grab another battery for this light. Give me 1 second. Alright, we're back. Darren, yeah, I've thought about using a spare grip. Problem with that is it's not how the blaster, or it's not how the gearbox and motor lives in the blaster. The grips can have different angles. The grips will put the motor in a different angle as well. And when we're talking about 0.1 of a mil, that's all it has to do to be out, and it can cause you issues. So I've had blasters come in and they're just out in their motor to pinion height, and that's what it does. So you can see the excessive wear on that bevel gear, and that was just a little bit out. Mind you, when we're pushing 330 FPS and trying to get it to fire at a high rate of fire, it puts a lot of pressure on your components. And they do tend to wear a little bit sooner normally when they're set up really good. So if they're sloppy or not set up properly, then you start stripping pinion gears, bevel gears, things like that. And this is the most important angle. I will spend a lot more time setting up the pinion to bevel height and also the motor depth than I will anything else in this blaster. So it is really important that we get this on point. So you can see down, see if I can see inside here. Get a good angle for you guys to check out there. Oh, I wish my phone would just... There we go. So we'll check a little bit of rock there, which we want just a little bit of gap. Also want to check rotational movement. So when it's too tight, I'll try and make what it is when it's too tight, so you guys can see the difference. So I've got the motor all the way in. So when it's too tight, you don't have any rock whatsoever. There's nothing there. That is like jammed right up against it. Now I can push it in, but I can't pull it back. It's because I'm dropping that front half of the gear, and as you can see, that rocks forward, but it doesn't rock back. And then your rotational movement is almost nothing because the teeth are just binding up against there. So you want it just a little bit back so that there's enough rock back and forward. See how I can get that to go back towards us and then away, and then I can get the rotational movement left and right. It is a bit difficult doing it this way with the J10 because you're just, the room you have to work with is almost nothing. But I do recommend doing it this way. I do recommend using the grip and lower receiver that you're going to use in the blaster. It just makes everything consistent. Yeah, because once you get it back together, and if you don't, if you start interchanging parts, interchanging motors, interchanging a lot of bits just to make it easier for yourself, if there's an issue and you need to diagnose it, you don't know if what you've done is correct. You don't know if the hand grip that you've now switched out hasn't caused you issues. You don't know, if you've changed to a different motor and a different pinion. I'd always double check my motor to pinion height and reshim it. You don't know, you just don't jam another motor and pinion in there, because everything can change. And like I said, when we're dealing with 0.1 of a mil, that's all it has to change, and it can just throw everything out. This is a game of 0.1 millimeters. So once we work out the height of your pinion to motor, my next step is then to just to match. Ooh, there we go. I then match. Sorry, just getting a shim off the bottom here. There we go. So that bevel is now shimmed, and the motor to bevel height is done. Do not touch any of the shims from top to bottom here. You need to match the other two gears to this gear. If we have a light, just switch that again, get a little bit better angle. And all we're trying to do from this point forward is just create a gap in between. Oh, God damn, I need better lighting. In between your spur and your bevel, there's a nice gap there, and in between your spur and your sector, there's a nice gap there. You don't want it to be too high, because you want as much contact between the gear teeth as possible. There we go. So the gap between the spur and the bevel is about 0.2, and the gap between the spur and the sector is about 0.1. If I raised, also the reason for that is I'm very limited in in how I can move that the spur gear. So I was actually thinking I might just cut a little bit more out of that gearbox, just so I can get a bit more adjustment out of that. Might be able to tighten up that gap between the spur and the bevel. Whatevs. See if I can get some more lights on here, guys. Be a bit better. So I might just take a little bit more out of this gearbox here, just so I can put a couple more shims in there and just get a little bit better meshing between bevel and spur. I'm really happy with the mesh between the spur and the sector. And then that's your 3 gear sets. So that's your 3 gear sets in a nylon box. It's the way I do it. If you guys got do it any differently, by all means comment, because I'm more than happy to change my methods and how I do it. More than happy to R&D anyone else's methods and give my opinions. If it works out better, then why wouldn't I adopt your guys' method? I always give you guys a shout out with people that give me great ideas. So once we do those gear sets, I pack up all my shims put them away, because you're in and out of this box. You still got to do the pump section. You still got to do your tapper plate movement, set up your angle of engagement, all of that stuff. So if you start dropping shims left, right, and center, you don't want other random shims around on your table, because then you don't know what the hell you've done. A really, really foolproof way to do it is to write it down on a piece of paper. Just write down, spur, bevel, sector, and then just top and bottom, and write down the amounts. If you put that off to the side, then when you go to service it next, you can change all the shims out for new ones, because their shims do wear, and then bring it back up to what it originally came out with, or what you guys had originally set it at, and then just double check. You can also, by doing that, you'll work out if there's any wear in the bushings or bearings. You'll also work out if there's any wear in the actual gearbox. So if those bushings have dropped down because they might have spun in the housing or something crazy like that, you'll find out when next time you service it if you reset everything back to 0. So how it originally was set. Now, there are a few little things I like to do to this box to just make it easier to work with, make it a little bit more reliable. There are a few fixes that people have explained to me and how they do it, and which I've adopted. So one of them is putting a spacer in for your semi-cutoff switch there. In the J9s, J10s, they don't. See how it rocks?